Good morning everyone. Today we students from IIT Roorkee are going to present our project Real-Time Gesture Recognition using Inertial Measurement and its applications. The domain of our project is automation and human-computer interaction. In this project, we have aimed to build a complete gesture recognition system using a 3-axis accelerometer attached at the end of a pen to detect the movement of a user's hand. Knowing the acceleration of the user's hand, this has significant potential to enhance the current human-computer interface, given that the hand movements can be used as an indicator of the state of the user. The purpose of our device is to create a low-cost gesture recognition device that can be trained to recognize various customized gestures and can thus be applied across a wide range of fields, starting from robotics, automation, home, industry, medical, all these fields. The current development is based on hidden Markov models, which has been proved that they are successful and highly efficient to recognize gestures. And we have tried to build a device, this whole system, as cost effective as it can, so that it can be used across all spheres of life.
I will explain the intricacies of the working of our equipment. Firstly, we have a 3-axis accelerometer with analog output. Then we have a microcontroller MSP430 FR5739 of TI origin. Then we have a RF transceiver for sending signals directly to the laptop. And at the end of the laptop, we have a receiver for receiving the signals. For powering the microcontroller, we have a battery installed of 5 volt, and we are for writing the code in the microcontroller, we are using an Energia software which is open source, and for processing the data we are using a MATLAB as our processing as for writing our code. Firstly, we take data through a 3-axis accelerometer which gives analog output to the microcontroller. We have attached the accelerometer to the end of a pen for making the user create efficient hand gestures. Now the data from the accelerometer goes to the accelerometer, where it is converted from analog signal to a digital signal. Then the signal is transmitted through the RF transceiver to the laptop. And the laptop gains access to the serial port which is connected through the MATLAB code. Now the MATLAB code receives the data and processes it using hidden Markov models which are used to recognize gestures from the data. The gestures that have been already pre-trained are used to detect what gestures are made. Okay. Now the code for running the microcontroller is as follows. Firstly we have initialized the microcontroller using the serial.begin function for initializing the microcontroller, and we have set the baud rate to 9600 bits per second. That is, the data transfer rate is 9600 bits per second. Then we have initialized 3 variables for taking values from x, y and z axis of the 3-axis accelerometer, and the data has been read using the analog read function from the respective pins to which the 3 axes are connected. 3-axis output of the accelerometer is connected, and then we have used a serial.println function to print the values of these 3 axes. And as you can see, this is the output of the accelerometer readings. As you can see, there are 3 values continuously being repeated as the loop is following, and we have only 1 values as something significant. Rest other values are 0 because x-axis is showing the g acceleration and rest all axes are at 0 acceleration. Now for processing the data, we have acquired the data into MATLAB using the serial port function using the data acquisition toolbox. And for processing the data, we have used a hidden Markov model toolbox that is implemented in the MATLAB. Now firstly we are taking the data from the accelerometer and are defining 4 gestures from 0, 0, 1, 2, 3. these are the 4 gestures that we will recognize while performing tests on the user. Now these 4 gestures are collected from the from 10 people, each doing each gesture 2 times. So we have a library of 20 instances of a single gesture. So a library of total 80 gestures we have created. Now we are using this library to train the hidden Markov models. Now after that we are using these hidden Markov models, trained hidden Markov models, to recognize our gestures that a user is making in real time. So okay, now we have defined 4 gestures, that is 0, 1, 2 and 3, corresponding to when we create a 0 gestures, it will type 1 in front of you, and when we create a 1 gesture, it will type 2 and so on. So firstly I am creating a 0 gesture in front of you. Now the MATLAB is pressing, and as you can see, the 0 digit has come in front of us. Now I am creating the one digit gesture. The processing is done, and as you can see, the 1 digit has come in front of our MATLAB. Now we are creating a 2 digit gesture. As you can see, processing is happening and the digit 2 has occurred in front of your screen. Now we are creating a digit 3 gesture, and as you can see, the processing is done and digit 3 is occurred on the screen.
Now let us look at the application of this device. This device has many applications. The main advantage of using these sensors instead of vision-based method is that the interface is not limited to a control environment. One of the major application of these devices is in automation and human-computer interface. In automation for home appliances, we can use this sensor to on off our home appliances like AC, to control speed of the fan and etc. In human-computer interaction, as we saw that we control our keyboard using these devices. Another application of these devices is in medical field, where doctor can use it for remote surgery, and for dumb people also this can be used as a sign language. It can even be used in industries for controlling various parts of machine and robot. Another efficient use is motion gaming, where various hand gestures can be used to control the motion in any video game. In the end, we would like to thank our mentor Dr. R. Balasubramaniam for helping us. We would also like to thank Texas Instruments for providing us such a great opportunity. Thank you.
Thank you.